Let's look at step number 2. In step number 2, we take glucose 6-phosphate and we transform it into its isomer, fructose 6-phosphate. Now, alpha-D-glucose 6-phosphate is not a compound that has a nickname. It's not a compound that keeps a specific name in the enzyme, and it's not a compound where we have no compound name at all. When something is not a 2,2,2, we said it's a phospho something, so we're going to call this enzyme phosphoglucose. Now let's look at the action. We're going from glucose 6-phosphate to fructose 6-phosphate. These two compounds are isomers. So our enzyme action is going to be isomerase. Remember, enzymes end in ASE. So we have a phosphoglucose isomerase. Let's look at step 3. In step 3, we're going from alpha-D fructose 6-phosphate to alpha-D fructose 1,6-bisphosphate. First, let's look at the compound name. Alpha-D fructose 6-phosphate is not a specifically named compound in our 2,2,2. It doesn't have a nickname, because only glucose and DHAP have a nickname. And we're not seeing an aldolase or an enolase reaction. We're not cutting off carbons or making an enol. So alpha-D fructose 6-phosphate is not part of our 2,2,2. Therefore, we know it's got to be a phospho something, because all the rest, if not 2,2,2, are phospho something. And in this case, we're going to be phosphofructo. Now, what's the action going on here? We're going from fructose 6-phosphate to fructose 1,6-bisphosphate. We're clearly adding a phosphate. So we know the enzyme suffix is going to be kinase. So the enzyme name is phosphofructokinase. And that's the K from Mad Ike. So far we've seen a kinase in step 1 and in step 3. That's the K in Mad Ike. The isomerase is the I in Ike. And again, in step 3, we have a kinase. So let's look at step 4. In step 4, we're going from alpha-D fructose 1,6-bisphosphate. And we're cutting that compound. We're cutting carbons. We're cutting a 6-carbon compound into 2 3-carbon compounds. First, let's look to see what we can put in for a compound name. Cutting carbons. When we cut carbons, that's going to be an aldolase. An aldolase is a type of lyase. Whenever you're cutting something, you're looking at a lyase. In this case, we're cutting carbons. So this is going to be one of our 2,2,2 enzyme names that has no compound name in it at all. It's going to be aldolase. In step 5 of glycolysis, we're going to convert, where are you? We're going to convert DHAP into glyceraldehyde 3-phosphate. Now you'll remember that these two compounds are isomers, so that's going to be reflected in the name. Now DHAP. DHAP has a nickname. That's one of our 2 compounds that has a nickname. Alpha-D glucose is hexo, and DHAP is triose phosphate. What's the action? Well, again, we have 2 isomers. So we're going to have the enzyme triose phosphate isomerase. That's the I in Mad Ike. In big step 6, let's see what we have. We're going from glyceraldehyde 3-phosphate to 1,3-bisphosphoglycerate. That's our bis 8. Let's see what the compound name would be in the enzyme. Oh, well, look at that. Glyceraldehyde 3-phosphate. is one of our two compounds that have their specific name in the enzyme name. So let's go ahead and write in glyceraldehyde 3-phosphate. What's happening between this compound and this compound name? Now let's look at what's going on here. We've already discussed this reaction, and we know we're losing the hydrogen on C1 of the aldehyde, and we're replacing it with a phosphate. So when we're when we're adding a phosphate from a compound, that would be a kinase. But we really have two different things going on. We are both adding a phosphate. Where are we? We are both adding a phosphate and losing a hydrogen. Now, which is more important? The dehydrogenase enzyme is more important, because ultimately down the road we're going to use the hydrogens that are removed and given to NAD in the electron transport chain to make energy. So let's give it its proper due, and we'll call this the D in Mad Ike, dehydrogenase. But we'll give a nod to the phosphate transfer by putting in the word complex. So complex tells us there's a whole other reaction going on too. Step 7 of glycolysis. In step 7 of glycolysis, we're going from 1,3-bisphosphoglycerate to 3-phosphoglycerate. So we're losing a phosphate. Already we know we're going to have some kind of a kinase going on. But first, let's look at the compound name that would be present in the enzyme. 1,3-bisphosphoglycerate is not one of our two specifically named compounds. It doesn't have a nickname, and it's not the aldolase or enolase enzymes that have no compound name at all. Since it's not part of our 2-2-2 rule, we know that it's going to be a phospho something, so let's call it phosphoglycerate. And again, we're removing a phosphate, so we're going to call it phosphoglycerate. Our word for moving a phosphate group is kinase. Now, where's that phosphate group going? This phosphate group on carbon number 1 is going to the ATP. So that's the transfer. So kinase is a transfer group, transfer name, and it's part of the major enzyme classification, transferase. In step 8 of glycolysis, we're just going from 3-phosphoglycerate to 2-phosphoglycerate. Now, right away, we say, well, they're isomers of each other, but since we're only having to move a phosphate group, and a phosphate group is not considered a functional group. What's the functional group in phosphoglycerate? Both phosphoglycerates, it's this carboxylate ion on C1. That's the major group. So we're going to take that phosphate group on 3, we're going to move it to 2, but we're not going to call it an isomerase, we're going to call it a mutase. Since it's not part of our 2-2-2 rule, we know this compound is going to be phosphoglycerate mutase. Let's go on to step 9. In step 9, we have the 2-phosphoglycerate, and we're turning it into phosphoenol pyruvate. We're making an enol. Right away, you should be alerted to the fact that enolase is one of 2 enzymes that do not have a compound name, so we could stop right here and write in the name of our enzyme. We know it has no compound name. The name of the enzyme is enolase. Finally, in step 10, we're going from phosphoenol pyruvate to pyruvate. Let's apply the 2-2-2 rule. Well, PEP is not in our 2-2-2, but pyruvate is. And remember, even though it's a product, the powers that be have designated that they think the pyruvate is more important, so they put pyruvate as one of our specifically named compounds in the enzyme name. So we have pyruvate. Let's look at the action. We're going from a phosphoenolpyruvate to a plain pyruvate. So we're losing a phosphate. And when you lose a phosphate, that's a kinase. And again, a kinase means we're transferring a phosphate between two groups we're transferring it to ATP. Doesn't matter whether the ATP donates it or receives it, whether we're giving it to an ADP or we're losing it from an ATP. If you're transferring a phosphate from one molecule to another, then that's going to be a kinase. So we have, that's the end of glycolysis. We use the two rules, the 2, 2, 2, and Mad Ike, and hopefully this will make it a little bit easier for you to go through glycolysis and put in the enzymes.